Okay, let's do another example of Gaussian elimination when applied to augmented matrices. Again, it's simultaneous equations, so we have three simultaneous equations. I am going to convert them into an augmented matrix. So we've got 3x plus 2y plus 3z equals 16. We've got 1x, 0y, 1z equals 4. 2x, 1y, 0 z also equals 4. So I now want to solve this. And the easiest way is to do this using Gaussian elimination, especially when we get into big ones like 4x4, 5x5s. So here's my matrix, and I'm going to start doing some row operations on here. So what I'm going to do is I'm going to go, what's the easiest way to deal with this? Looking at this, I'm going to go do some swaps. I'm first of all going to swap. Remember, I'm going to call this A, B, C. The first thing I'm going to do is I want that 1 up the top. So I'm just going to swap A for B. So now the new format looks 1, 0, 1, 4, 3, 2, 3, 16. Because remember, these are equations. You can just swap equations around. That's cool. That's done. Now I can do two operations. So as I said, in the last example we just did one at a time, but I'm going to do two at a time here. I'm going to subtract this row from this, but I want this to equal 0. So I'm going to go, so A, B, C. I'm going to go 3 times row A minus row B. I can do the same thing down here. I can go 2 times this row, the new version of this is going to be 2 times row A minus row C. But we'll do these one row at a time. So I put my new matrix down. So the first row does not change. 1, 0, 1. That's it. I'm now going to go 3 times this row minus this row. So this is 3 times 1 is 3, minus 3 is 0. 3 times 0 is 0, minus this row is minus 2. 3 times that row, so 3 times 1 is 3, minus 3 is 0. 3 times 4 is 12, minus 16 is negative 4. That's pretty cool. And again, I'll do it the same here. I go 2 times row A, 2 times 1 is 2, minus 2 is 0. 0 minus 1 is minus 1. 2 times this row, 2 times 1 minus 0 is 2, equals 2 times this, 8 minus this. So we now have this. Looks really cool. But I don't like these negative numbers here. And so I'm just going to go row B minus 1 times B minus 1 times row C. Because remember, rule 2 says you can multiply by a scalar. It's row A, B, C. Not touching row 1. 1, 0, 1, 4. Row B, I'm going to go through and multiply everything on that row by negative 1. So negative 2 times negative 1 becomes positive 2, 0. Negative 4 times negative 1 is 4. And I'm going to do the same here. This is just a tidy up. So minus 2, minus 4. Just allows me to have a nice little positive one down there. Okay, so I'm also going to divide this row 2 by, I'm just going to divide that by 2, half B. I should probably have done that before. So that now gives me 1, 0, 1, 4, 0, 1, 0, half of that is 2, 0, 1, negative 2, negative 4. Now what I want to do here is I want to get rid of this 1. So I now go for row C, I go row B minus C. It just makes it easier for my brain. So again, I don't touch row 1. I don't touch row 2. I just said I was only going to be touching row 3. And row 3, I go 0. Row B, this row minus this row is 0. This minus 2 is positive 2. 2 minus 4 is 6. So I can then take this up, just divide by 2. So I'm going to go row C divided by 2. Let's go see what we've got. 1, 0, 0, 4. 0, 1, 0, 2. 0, 0, and dividing this by 2, 1, 3. So let's have a look. Basically, equation C says that Z equals 3. That's cool. Equation 2 says that that Y equals 2. Again, that's nice. Equation A says that X plus Z equals 3. Equals 4. I know what Z is now because I worked it out. We said that Z is equal to 3, so X plus 3 equals 4. X is equal to 4 minus 3, so X is equal to 1, so X equals 1, Y equals 2, Z equals 3. We can, if we want, check it by sticking it into the original equation. X is equal to 1, so 3, plus 2 times 2, 4, 7, plus 3 times 3, 9, so 7 plus 9 is 16. So seems reasonable.